In the last video, we defined average rate of change and instantaneous rate of change. So the average rate of change was between 2 points, and the instantaneous rate of change was at a specific point, at a specific x. But what if we wanted to create a formula for instantaneous rate of change for any x? So this is called the derivative. So the instantaneous rate instantaneous rate of change is at a specific x, and the derivative is going to be a function, a formula for the instantaneous rate of change, and then you can plug in the x to find it at a specific x. So here comes notation. It's going to be very important for the rest of this calculus class. For y equals f of x, we define the derivative of f at x denoted f prime of x. So derivative is going to be for the rest of this calculus class, so get used to this f prime of x. So that prime part is a little superscript, and the definition of the derivative is the instantaneous rate of change definition, but instead of using a, instead of being at a specific a, we have it for any general x. So it's going to be the limit as h goes to 0, right? We're making the distance smaller and smaller between 2 points, and then what we call the difference quotient. Again, a couple of words to get used to. If the derivative exists, then f is said to be differentiable. The process of finding the derivative is called differentiation, and the derivative is obtained by differentiating the function. So sometimes the instructions, as you can see right below, it says differentiate the following functions. You can also be asked find the derivative or find f prime of x or so on. So remember that when we were doing the instantaneous rate of change in the previous video, these questions are very algebra heavy. It's about 95% algebra, and then at the very end, you actually evaluate the limit. So your goal is to evaluate the limit. So you want to plug in h equals 0, but the way it currently is, you cannot because there's an h at the bottom. So your goal is to simplify the difference quotient, and the difference quotient is this part. And that's what you learn to do in algebra, so that you cancel out the h and then you can take the limit. So the limit is going to be the very last thing you do. So we're going to have two examples. We're going to have a polynomial and then a rational. Surprise, surprise. So let's start off with the polynomial because it tends to be a little bit easier. So the first thing I'm going to do is I'm actually going to take care of the f of x plus h part, which is exactly the same thing I did when I was doing the instantaneous rate of change. So when I plug this in, that means that everywhere there's an x, it gets replaced by x plus h. And then I need to simplify this. So I'm going to FOIL out, because remember, this means x plus h times x plus h. You can't distribute the squared. We saw that last time too. So it becomes x squared plus 2xh plus h squared. I'm going to distribute the 5. Don't forget that the x goes with it, that the negative goes with it. I was fixing my mistake. And then we're going to distribute the 3. And then we look to see if we have any like terms, and none of them are like. The first one is x squared, then xh, then h squared, then x, then h. Nothing is alike, so this is as far as we can go in terms of being simplified. The next part I'm going to do is now I'm going to start plugging it into the derivative formula. You must always label your derivative. It is a function. It needs a function name. It's not an expression. It's a function. So the limit always goes in the front. And then I'm going to write the formula one more time. Anytime you're trying to remember a formula, it's always good to keep rewriting it. So just to color coordinate a little bit, this f of x plus h is going to be replaced by the simplified version of f of x plus h. And then the f of x is the original f of x. Now, the key to remember, and a very common mistake that I see in these types of questions algebraically, is that people forget about the negative here. So the negative is in front of the entire f of x. So be very careful with that because you need to distribute the negative to the entire x. So here we go. So don't forget about this negative. All right, so let's start plugging things in. Equal to, I can't forget about my limit. That's going to be very last. So this little guy is going to have to be carried with me the entire time. So first I'm going to do f of x plus h. So 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 1. And this is where you got to be careful. So now you're going to do minus, and you're going to put f of x in parentheses. So f of x was 3x squared minus 5x plus 1. And that's going to be all over h. So what happens is that you're going to take this negative and distribute it to every term. So it's going to change the sign of all three terms. So I'm going to come back over here, have a little bit more space. Again, my limit is carried with me, carrying it like a purse right in the front. So I'm going to have my f of x plus h. It doesn't change. And sometimes when people get comfortable with these types of questions, when they're plugging in f of x, they immediately distribute the negative, right? Just be careful with that. If you're doing it, just make sure you're doing it correctly. Okay, so I distribute the negative. And some magic is going to start to happen here. Maybe you remember from algebra. Things are going to cancel. So the 3x squared, the positive 3x squared cancels with the negative. Remember, it can only cancel when they're opposite sign. The negative 5x cancels with the positive 5x. And the positive 1 cancels with the negative 1. So I'm going to write what I have left over. This is equal to, the limit as h goes to 0, of 6xh plus 3h squared minus 5h all over h. But what's happening is that every term in the top has an h. So I'm going to be able to factor out an h. So again, I'm carrying my little purse in the front. Can't forget about that guy. I'm going to take out an h. I'm left with 6x plus 3h minus 5. And again, this is all over h. So I took out an h from every term in the top. And now, this is our goal. This is the magic that's happening. This is exactly what I wanted. The h is canceled. And because I canceled the h in the denominator, I can now plug in my limit. So I'll write it one more time for emphasis. And our go-to for limits is to plug it in. I'm going h. H is right here. So this is going to equal to 6x plus 3 times 0 minus 5, which is 6x minus 5. So this is the derivative. I'm going to write my answer, my final answer, all nice. F prime of x, I have to label my function 6x minus 5. So this is the instantaneous rate of change, or for short, rate of change at any x of the function. So for example, if I plug in x equals 1, I get 6 minus 5, which is 1. So at x equals 1, the rate of change is 1. If I plug in 10, I get 55. So at x equals 10, the rate of change at that point is 55. So it's increasing, it's growing. And remember that the instantaneous rate of change is the slope of the tangent line. And I'm going to repeat that at the very end of this video. Let's do rational function. So here we have g of x, so that's fine. So it's going to be called g prime of x. We'll write the formula one more time. Like I said, anytime you're trying to remember. And here we have a g. Don't let that confuse you. Right, it's just the name of the function. You could use smiley face if you wanted. And here I'm going to directly start putting things into the formula because the g of x plus h, I really can't do anything much with it. So it's going to become 5 over x plus h minus 1. I'm replacing the x with the x plus h minus 5 over x minus 1 over h. So this is called a complex fraction. If you haven't done that in a while in algebra, you can Google it, YouTube it, complex fractions, all right? Obviously, I'm going to have to take care of it now, but if you'd like a few more examples. So what I need to do is I have fractions over fractions. So I'm going to get rid of the two denominators, which are right here. So this is my first denominator. This is my second denominator. And I'm going to take those and multiply them by the top and the bottom. Because if whatever I want to do to the numerator, I have to do to the denominator. So I'm going to multiply by x plus h minus 1 times x minus 1 over x plus h minus 1 over x minus 1. And in the top, I have to distribute to this and to this. And in the bottom, I'm just going to distribute it to the h. So what is that going to give me? That's going to give me the limit as h goes to 0. When I distribute it to the first fraction part, the 5 over x plus h minus 1, the x plus h minus 1 is going to cancel. And I'm going to be left with only the x minus 1. So this is going to be 5 times x minus 1 minus. When I distribute it to the one with the blue, the x minus 1 will cancel, and I'll be left with the x plus h minus 1. And in the bottom, nothing cancels. So I'm going to leave it like this. Don't FOIL out, because remember, you're trying to cancel out that h. So don't start distributing it. Okay, so now what I'm going to do is I'm going to distribute the 5 both times. So I'm going to distribute it to, it's going to become 5x minus 5. And in the second one, I'm not only distributing a 5, I'm distributing a negative 5. So it's become negative 5x minus 5h plus 5 all over h times x plus h minus 1 over x minus 1. And here comes the magic. So the positive 5x and the negative 5x cancels, and the negative 5 and the positive 5 cancel. So I actually only have one term left there. It's going to give me the limit as h goes to 0 of a negative 5h over h times x plus h minus 1 times x minus 1. Ooh, does anyone see it there? Here it comes. The h can cancel with this h, and I no longer have that problem, so now I'm going to be able to plug in my limit. I'll rewrite it one more time for emphasis. So here it goes. Here's the h. That's going to become 0. So that's going to give me negative 5 over x minus 1 times x minus 1. But simplified, we can actually write that as x minus 1 squared. So I'm actually going to write my final answer with my function name. So it's going to become g prime of x is equal to negative 5 over x minus 1 squared. So if I wanted to find the rate of change at x is equal to 3, I would plug in x is equal to 3 into the derivative, and that will give me my rate of change, which is the slope of the tangent line. I wrote this at the bottom in red, super important. Really, really try to drill this in, because this is going to be something you're doing for a long time in this class now. The derivative is the rate of change, which is the slope of the tangent line. These three things mean the same thing. So you want to really try to remember that, because when it asks you for one, you need to be able to relate it to another one. So here's a polynomial example and a rational function example. Again, very algebra heavy, so just be careful with your manipulation.